Welcome to another video for algebra. In this video we're going to solve linear systems by substitution. If you recall in the previous section we were solving linear systems by first graphing the equation and then identifying where the intersecting point was in those two equations, in those two lines. And in order to graph those two lines, I needed to transform my two equations into my slope-intercept form. That way I could have a y-intercept and then the slope helping me to graph my lines. Well, in this particular method, by substitution, we don't need to graph a line. We're actually going to pinpoint the exact point at which these two equations meet, they intersect. But this is done without actually graphing the line. So since I don't need to graph a line, I don't need slope-intercept form. All I need is to isolate one of my variables. So again, this method is called substitution. So I'm going to use my isolated variable, and then I'm going to substitute whatever that value is into my second equation. So let me work this out for you so you can see. So the first step that I want to do is I want to first look at both equations, and I want to identify the easiest equation to use to isolate the variable. The easiest equation would be the one that would require the least algebra to do or to use in order to isolate a variable. So just by looking at both of these, this one sticks out to me as the easiest. It looks like there's less numbers to work with and less algebra to use. So why would that be? As I just stated, it would require the least amount of algebra to isolate a variable. Okay. So here's that equation. I have x minus y equals 0. Now I could either isolate for y or x. It would be easier for me to isolate x because all I have to do is add. So then when I add y to both sides of this equation, I'm left with a positive x equals y. Well, it couldn't be any easier, right? X equals y and y equals x in this case. So I can actually use either one of these to substitute. I can either substitute x or y. In this case, I'm going to go ahead and substitute y. So I look at y in my second equation, and I know the value of that y now. That value is x. So I can now replace that for y, I can replace with x. And if you'll notice, that'll do one very specific thing for me. It's going to give me one variable in that equation, and now I can actually solve for that one variable. I'm left with 2x plus 4x equals 18. And that's 6x. Okay, now I just need to continue my algebra by dividing by 6. That leaves me with x equals 3. So now I have the value for x. So my next goal is to then identify the value for y. Okay, so you'll notice that I want to replace x. Where it says x equals y, I now know the value of x, and that equals 3. So I'm going to replace x with 3. So y equals 3. And as it turns out, both x and y equals 3. Don't let that befuddle you there. That's okay. Because remember, the goal is to find the solution. It is to find the point of intersection for both of these equations. All x and y are coordinate points. So the next thing that I do, okay, so my coordinate point is 3, 3. Now what I'm going to do is I'm going to highlight my work here. I have my coordinate point and I have my two original equations just so you can use them as reference, and then I'm going to plot my point. So my point is at 3, x3, y3, and that's my point. So I don't even know what my lines look like because I didn't use slope-intercept form to plot points and to draw a line. It's not important in this case because all I need is the solution. Okay, and I was able to attain that solution without using slope-intercept form. I just used a substitution method. Okay, well I hope this helped, and good luck in your study.